Section 9.2, Intermediate Algebra. In this part, we're going to take a look at some variations of the exponential function and what it does in terms of the shape of the graph. We call these translations. And in this first example, they're asking us to graph the function 2 to the x plus 2 power. When all else fails, if we're not sure about what a change in our basic a to the x power does in terms of shifting our graph, when in doubt, it's always a good idea to just substitute a value for x and make some calculations. So let's do that. And then we'll compare it to the basic form of a, in this case, 2 to the x power, and how adding a 2 to that exponent is changing the shape of this graph. So we will plug this in to our function, various x values. Let's start with x equals 0. So we will have 2 to the 0 plus 2, which would be 2 to the second power. 2 to the second power is 4. If we put a 1, we'll have 2 to the 1 plus 2, which is 2 to the third power. 2 to the third power is 8. We can see our our x values, as they increase, are going to give us larger and larger y's. Let's see what happens with negative exponents. So replacing x with a -1 and adding 2 to it leaves a 2 to the first power, or 2. A -2 would be 2 to the -2 plus 2. And I'm replacing the x with these values in the exponent. That leaves us with 2 to the 0 power. Anything to the 0 power is 1. And let's do just a couple more points here. X equal -3 would be 2 to the -3rd plus 2, which leaves us 2 to the -1, or 1/2 power when we take it to the denominator to eliminate that negative exponent. And one more, as our x's are decreasing, we would have 2 to the -4 plus 2 power, which leaves us with 2 to the -2. Taking that to the denominator, we end up with 1 over 2 to the second, or 1/4. And as our x's decrease, we can see that's getting smaller. Plotting these points then, 0 is at 4, 1 is at 8, which is going to be up here. Then we shifted -1, had a value of 2. -2 was at 1. -3 was a half. -4 was a fourth, and so on. Connecting those with a smooth curve, it has the look and characteristics of an exponential function. As our x values are getting smaller, it's approaching the horizontal line, acting as the asymptote, and as it's moving from left to right, it's increasing without bound. Nothing is stopping it. Our domain is all real numbers. We do not have our x-intercept, or our y-intercept at x equal 1. Rather, it ended up moving up a couple values here. We have it at the point 0, 4. So if we compare this, we can see we ended up with a translation vertically. This is the generic f of x is equal to 2 to the x power, and we have x plus 2 on our value, seeing that it is going to increase faster on our function having an additional value in the exponent. Let's see what happens when we take a exponential function, and this time instead of adding to our exponent, we subtract our exponent, and see what that has, what kind of effect it has on our graph. And again, we'll plug in some values to get a sense of the shape of this graph. So we'll have 2 to the 0 minus 3. That leaves 2 to the -3. That's 1 over 2 to the third power, which is 1/8. Putting in a 1. 1 minus, whoops, I guess I better use the right value though. 1 minus 3 leaves a -2. So we have 1 over 2 to the second power, or 1/4. It's getting larger value. Let's put a 2 in there. 2 to the x, which is a 2 this time, minus 3 leaves 2 to the negative 1, which is 1/2. We'll do a 3, 2 to the 3 minus 3 would be 2 to the 0, which is equal to 1. 4, we can see that we've now tipped the scale. We're going to have ever increasing powers on our variable. 2 to the 4 minus 3 would be 2 to the first power, or 2. Putting a 5 in, 2 to the 5 minus 3 power is going to give us a 2 to the second, or a 4. Let's put a negative value in here. We'll put a x equal negative 1. So we would have 2 to the negative 1 minus 3, which is going to give us 2 to the negative fourth power, which will be 1/16. So plotting these points, we have negative 1 is 1/16. Starting at the top, we have 0 is at an 1/8, so up a whisker more. 1 is at 1/4. 2 1/2 is the next ordered pair that we had. We had x of 3, y of 1. We have the ordered pair 4, 2, so over 4 and up 2, 5 over and up 4. And I guess we have those values. And if you notice, we still have increasing from left to right, a little shaky there. There's no reason that this value will get ever small as our x decreases, but again, it's acting in the manner that an exponential function does, that it will never cross the x-axis, acting as an asymptote, a barrier, and it increases without bound. We still have the domain of all real numbers. Our range will be all positive values. But taking a look at kind of the parent exponential function, f of x is equal to 2 to the x, having that minus 3 added on in our exponent has slowed down this heading towards positive infinity and has translated it actually. Here is our y value, our y-intercept on this function is at 0, 1, and if you notice, we have a translation of 3 to the right. Here's what happened to that y-intercept. It's 3 points further to the right. So the translation is moving, and just to show you back to the first one that we just did, where is that point that was our y-intercept? On this one, where we're adding to our exponent, notice here is where our original y-intercept was. It's now shifting or translated to the left. So adding to our exponential power is going to shift our exponential function to the left in comparison to its original form of the y equals 2x. Here we have our intercept at 0, 1, y-intercept, and one more time, looking at this graph, the x minus 3 ended up translating our graph over 3 to the right and then continuing on up. Let's look at one other variation on the exponential function. We have the parent function 2x, but we're going to add 3 to our value, and let's see what that does to that general form of the exponential function 2 to the x power. So again, when in doubt, you can always set up a table, plug in the values, and plot the points from there. We'll start with x equals 0. 2 to the 0 is 1. 1 plus 3 is 4. If we put a 1, 2 to the first is 2, plus 3 is going to give us 5. If we have a 2, we'll have 2 to the second power plus 3. That's a 4 plus 3 is 7. We can see it's increasing as our x values get larger and larger. Let's get a couple negative values in there. We'll have 2 to the negative 1, which is 1/2, plus 3 is 3 and 1/2, or 3.5 if you'd like the decimal form. A negative 2 would put 2 to the negative 2. That's 1 over 2 to the second, or 1/4, plus 3. So this will be 3 and 1/4, or 3.25. Let's plot these points then. We have 0, 4. We have the ordered pair 1, 5. We have the point 2, 7. And on our negative x values, we had a negative 1 at 3.5. We have negative 2 is at 3.25. And a smooth curve to connect those points together. We see that it's increasing from left to right, but this time we have a sense that as our x gets smaller and smaller, instead of having the x-axis act as our asymptote, instead we are going to have our y equal 3 act as the asymptote. So here, this graph was a translation vertically up 3 from, again, that parent function of f of x is equal to 2 to the x.